Welcome to today's webinar, Introduction to Efficient Lighting and Controls. Glad all of you can join us today. Just so you know, all of PG's seminars and webinars are in part sponsored by the Energy Trust of Oregon and the Northwest Energy Efficiency Alliance. We work together to make sure the concepts and recommendations you learn in our classes are consistent across all of our individual programs and services. One of my favorite things to do at PGE is working with commercial and industrial customers to help them with their lighting efficiency projects. So I plan to share some of my favorite tips and suggestions with you today. So here's today's agenda, and the main themes throughout are going to be saving energy, saving money, and also providing better quality lighting through a lighting upgrade project. So throughout this webinar, I want you to think of a lighting upgrade application at your business site that you're considering, or just pick one that you're interested in. The goal today is to supply you with information about lighting and energy efficiency that will make a difference at your place of business. I'll start with some lighting basics and then quickly move on and show you how to apply this information for your particular project. So we invite your active participation today, and one way to do this is by using the annotation tools located on the upper left-hand side of your screen. In fact, I'll ask you to use these tools on the very next slide. And we plan to leave time at the end to answer your questions. So these are the key learning objectives for today. So if you would, please use one of your annotation tools to indicate to me which one of these are of most interest to you today, either a pointer or a line, whatever works for you. So during the early part of the presentation, we'll focus on how to get light to the work plane effectively and efficiently. Throughout the presentation, I'll share several energy-saving lighting upgrade applications. The focus is going to be on retrofit, but new construction applies also. Toward the end, we'll go over how to save energy with controls by focusing on occupancy sensors. And after we've learned a few things today, I'll let you know how you can get help with your lighting upgrade project. And it looks like most of you are interested in applications and also controls. Thanks very much. So let's start at the beginning by defining what light is. Essentially, light is radiant energy that we can see. And light is light whether it's from the sun, fire, or electric light sources. However, there are many variables about light, and we'll discuss a few of those today. Normally, we're looking at reflected light, unless you're a lighting geek like me that's looking up all the time. And our eyes are designed to be sensitive to this energy. So this radiant energy can be represented visually by the electromagnetic spectrum. There is a very small band of visible light that our eyes are sensitive to from around 380 to 780 nanometers. So you can see that all the colors of the rainbow are represented by those bands. So what's important about this is that light quality is very much related to the amount and the intensity of the light spectrum in a particular light source. So just a little bit about how our eyes see light and color. Our eyes detect visual images on the retina located at the back of the eye. And this allows us to see, and we have different receptors. We have the rods, which allow us to distinguish between light intensities at lower light levels. Keep in mind we have very few color cues at low light levels, and there are lots of rods. They're scattered throughout the retina. The cones, on the other hand, they allow us to distinguish color at higher light levels. And we have far fewer cones, and most are located in the fovea, which represents about a 2-degree view of optimum vision. This is where we can focus. So knowing a little bit about how our eyes work can help us with our lighting design strategies. Color Rendering Index, or CRI, is one of the ways we can quantify color quality. It's rated on a 0 to 100 scale, and this indicates the effect of a light source on the color appearance of objects. And there are 8 color samples that are rated and scored for accuracy. That's how this works. It's not a perfect metric, but it works pretty well for most sources. But we're finding that it doesn't work as good for LEDs, that test better with more saturated colors. So it's possible we'll have a new metric. Color quality scale is one that's being mentioned on that, but I think it's a ways off yet. So to give you some perspective, the sun is a perfect 100, no surprise there, has all the colors of the rainbow. Incandescent sources are usually very close to 100, and this is why retail stores still like to use halogen track lights. But we'll find out later that LED is going to be a good alternative for that. High pressure sodium is an example of a very poor CRI. It's very close to 20, and it's also very yellow. The older T12 fluorescents that we'll talk about today have a very poor CRI. A CRI of at least 80 is considered very good. Your better quality fluorescent is an example of this range of CRI. Now, some applications like high-end retail museums need a CRI of at least 90, while some applications like warehouses and exterior lighting may only need a CRI between 70 and 80. The other significant color metric is correlated color temperature, represented by the letters CCT. And this is measured on a scale called Kelvin, which is represented by the letter K. And this indicates the relative warmth or coolness of a light source. From around 3200 and below, it's considered to be warm. That's on the red side of the spectrum, and once you get over around 4000 K, it's considered to be a cool light source because there's more blue on that side of the light spectrum. And CCT is subjective as well as an objective metric. Most people's skin, for instance, looks better under warmer colors, and that's because there's more red in the light source. However, most tasks, we can see tasks better under cooler sources. And the reason for this is that there's more blue in the spectrum, and we found from the research and studies that this helps make our pupils smaller, which allows us to see more clearly. So there's fewer rays that aren't going into the fovea that we looked at earlier, which represents our highest degree of focus. So if you squint or look through a small pinhole, yes, you really do see better. So because of this phenomena of seeing tasks better under cooler sources, using higher color temperature lamps may allow us to save energy if light levels can be lowered and still enable us to see well. So this is going to be another slide to use your annotation tools in a minute. So I have those at the ready. As you can see on this graph, the larger the number, the cooler the light source. And all sources have a range of color temperatures. And some are small, like your halogens and incandescents are from around 2700 to maybe 3200, while fluorescents, CFLs, and the linear fluorescents and LEDs, they have a large range of color temperature options. So the question I'm going to ask is, for your application that you're thinking about, what color temperature is best for your application? Go ahead and mark that on the chart somewhere. So fluorescent sources can vary their color temperature by adjusting the mixture of phosphor coating types that are used to make white light. Although all phosphor appears white, there are variations in the types of phosphors that transform light either warmer or cooler. And we still have some people making some choices. Looks like we like cooler light sources today. Thanks very much. So let's turn our focus now on some common lighting terms and how to get light where you want it in an efficient way. So getting light where you want it begins with a light source. And we're going to have input power, and then we have light output. So putting those together as a metric of efficacy is lumens per watt. So many people use the word efficiency, but efficacy is actually the more correct term. Think of miles per gallon. Now, the place where you want light to go is known as the work plane. And getting light to the work plane in an efficient manner saves energy and also saves money. So a high efficacy rating is a good place for us to start our light journey. So let's look at some common light sources and see how they compare in efficacy. So this is a chart I put together to help you visualize that just like with color temperature, light sources have a range in efficacy. Up here at the top, we can see that the incandescent and halogen sources are the worst in lumens per watt. Compact fluorescent is better. Linear fluorescent, here's the T12s, and you'll notice that the T8s and T5s, any of those, even the worst ones, are better than the best T12s. One thing you notice on this chart is that both metal halide and LED, especially LED, have room for improvement, while the other sources have pretty much peaked as far as how good they're going to get. Very little room for improvement. With LED, they're saying that we might even see lumens per watt of 250 lumens per watt someday. But keep in mind, efficacy is just the starting point of our light journey. So next we're going to see which fixtures allow the most light to actually escape the fixture and even have a chance to reach the work plane. Electric light sources are going to be housed in some sort of luminaire or fixture. So picking the right one is very important. And luminaire efficiency is the ratio of the lamp lumens leaving a luminaire relative to the lumen output of the lamps going into the luminaire. And this is expressed again as a percentage. But even though we can see that this one lamp strip fixture is more efficient than 3-lamp parabolic, we may not want that high glare of that bare lamp, and we may not want the light to go everywhere. So in a parabolic fixture, we have these louvers that direct the light where we want it to go, but you're going to lose some efficiency when that happens. And generally, the more light control, the lower the efficiency. One way you can improve a parabolic fixture, and we'll talk about this later, is that you can replace that parabolic louver with a more efficient lens. You could take this very same fixture and improve it from 65 to over 85% efficiency. So for this illustration, think of the light source here as a T8 fluorescent lamp inside a recessed Troffer fixture with a prismatic lens. So some of the light rays are going to go directly from the lamp to the work plane, while others are going to take an indirect path or get absorbed and never leave the fixture at all. So two important things to remember is all objects are going to reflect light to some degree, and all are going to absorb light. And if you have a lens, there's going to be a transmission factor like we have through this prismatic lens that we're illustrating here. So again, why are some fixtures more efficient than others? Well, the answer is that we lose some light every time it strikes a fixture surface or goes through a semi-transparent material. So the question is, would the color of walls and ceilings and office furniture make a difference in getting light to the work plane? Absolutely. Light will also reflect off of walls and objects in the room. So only some of the light rays reach the work plane directly, and others take an indirect path. So you can save energy with lighter surfaces and more efficient fixtures. Talk a little bit about foot candles, which represent the average amount of light spread over a work plane surface, or the amount of light from one candle, 1 foot distance, 1 square foot in space. Let me go back here for a minute. So when light finally reaches the work plane, we can measure the amount of light in foot candles. One thing before we get to that is it's important to know that distance matters with light. So the same 1 foot candle, if the place that you want to light the work plane is 2 feet away, you don't have a 1/2 foot candle, you're going to have a 1/4 foot candle, because light is affected by the distance squared. So that's very important to know. Okay, so now we've got the light reaching the work plane, and we have a light meter, and we can measure the amount of foot candles. So the work plane could be horizontal, like your desktop or the floor, or it could be a vertical work plane, like a whiteboard or maybe a retail display. So the Illuminating Engineering Society publishes the big lighting handbook, and they group light in different categories. And here's a few examples for your reference here. So for low light levels, 0.1 to around 3, this is orientation and maybe large-scale physical tasks, mostly exterior. This 3 to 20 range, this is common social activities. This is a combination of inside and outside. So 20 to 75 is light levels that we're mostly seeing indoors for reading and writing, common visual tasks. And then we need more light as we get into small-scale tasks and jobs like inspection. And we can go up much higher for doing tasks that have the highest visual performance. Surgery would be a really good example of that. Keep in mind that many applications are currently overlit, so there are opportunities to save energy in retrofitting by adjusting light levels lower whenever that's appropriate. And in case you've never seen a foot candle, here's what one looks like. Okay. So we finally got our light to the work plane, and that's great. But another thing we need to consider is what happens to light over time. All lamps lose light over time, some much more than others. So this is something that we have to account for. So this graph illustrates the depreciation curve of a common T12 lamp and contrasts that with the T8 and the T5, which is much, much better. So a good light source should maintain 90% or more of its light output over time. So you can save energy by not having to overlight a space initially in order to allow for a significant loss of light over time. Now in this messy graph, you're going to see different light sources that are commonly used today go well below that 90%. Your 8-foot T12s, your HOs and VHOs, mercury vapor, metal halide, all of these lose a lot of light. So again, you either have to way overlight the space to allow for this depreciation, or you put up with maybe 40% light loss over time. And there's other depreciation factors that we won't talk about today, but most of these involve dirt. So one more design concept to know is how far apart fixtures should be to give us even illumination for different ceiling heights, which is normally what we want when we have ambient lighting from the ceiling. Give you a heads up that this slide is going to have a one-question quiz. So this is known as spacing criterion, and it's the ratio that's used to calculate the maximum recommended installation spacing to obtain an even pattern of light. So in this example down here, and you get this number on the fixture specification sheet. So you go look at a fixture, and if they have a good specification sheet, they're going to include the spacing criterion number. So in this example, the spacing criterion is 1.1. So we multiply this times the ceiling height, which is 10 feet, and that's how we get 11 feet. That these particular fixtures should be no more than 11 feet apart to maintain that even illumination. Okay, so here's the quiz. So what if the spacing criterion was 1.2? So how far apart should the fixtures be spaced? And here's your three choices. So indicate which one of these. If the spacing criterion is 1.2, how far apart should the fixtures be spaced? Now keep in mind that this criterion applies to relatively open spaces. So if there's a lot of high cubicle walls, partitions, you may want to space fixtures just a little bit closer together. And everybody gets an A. Great, thanks. So in this next section, we're going to discuss two common lamp families, incandescent and fluorescent. But first, I want to go over some lighting terms that help us describe lamps. And unfortunately for some of you, this is going to involve a little math. All light sources are designated by a letter, and this designates the relative shape of the lamp, and then it follows by a number. And this designates the maximum diameter in 1/8 of an inch, and that's where the math comes in. So for example, down here, our common T8, which we all talk about, the T stands for tubular, and the 8 stands for 8/8 of an inch, or 1 inch. And that's where the easy math comes in. T12 is going to be 1.5 inches. Here's a globe that's 30/8 of an inch, or 3 3/4 inches for those of you without a calculator. A parabolic aluminized reflector lamp is par 38 is 4 3/4. MR16 2 inches, and so on. So now let's start our lamp family discussion with incandescent, and we'll talk about some energy efficiency legislation that's been in the news a lot lately. So incandescent light bulbs haven't fundamentally changed since they were invented over 130 years ago. So why do we still use them? Well, they're inexpensive, we can get them anywhere, people know how to use them, color rendering is good, and maybe one of the reasons that we're using them is the most is because they're easily dimmed. But they also have a lot of disadvantage. The efficacy is low. That's because more energy it goes to heat than light. The lamp life is short, and I'm not sure if this is really a disadvantage, but a lot of the common types are no longer going to be manufactured. And other legislation covers directional incandescent lamps and also fluorescent lamps and ballasts. So it's not the common light bulb that's affected. And keep in mind in the future discussions here that halogens is another type of incandescent. So this chart specifically compares the replacement options for the common light bulb. However, this discussion example is going to apply to other light sources as well, not just incandescent and LEDs. So from now on, you're going to have 3 replacement options. The new lighting law began to take effect January 1st of 2012. That started with the 100-watt bulbs, and last year the 75-watt, and this year the 60 and 40-watt bulbs were affected. So one way to look at your choices is good, better, and best, with good being energy-saving incandescent, again a halogen, better CFLs, and the best being LEDs. But we can look at this chart and compare these 3 lamp life. You can see that LEDs definitely have the most lamp life, but they're going to cost the most. They're going to give us the most energy savings, most dim well, some don't, and the color quality, especially for the best LEDs, is excellent. So if you want a more detailed chart, you can find this on PGE's website under the residential section under saving energy at portlandgeneral.com. So the important thing here is that you need to do your homework. You need to make your choices based on your application, hours of operation, and what features and benefits are important to you. So here's some energy-saving bulb examples from GE, Philips, and Sylvania, known as the Big 3 of lamps. So energy-saving incandescents, they still make sense for applications with low hours of operation, where you want dimming, and maybe the warm color temperature shift that incandescents give you when you dim them. Now CFLs are going to be better for applications that have longer hours of operation. You don't need to dim them, and there's infrequent switching, because switching is going to wear out compact fluorescence and linear fluorescence. Now the LEDs are going to be best for applications with very long hours of operation, where bulb replacement is expensive or difficult, where you want dimming, and also frequent switching. LEDs don't mind frequent switching. And some LEDs now will even color shift warm when you dim them, just like incandescents.
Hey, Mark, I have a question on the LEDs. What's the latest on cost? Aren't the bulbs kind of expensive?
Absolutely. LED lamps right now are much more expensive than CFLs or incandescent, but the cost has been coming down dramatically. In fact, a lot faster and a lot more than most people predicted. You can get a lot of these 60-watt replacements at various places for $10 and sometimes even less. Thanks, Beth. So until recently, there just hasn't been an acceptable alternative for halogen reflector lamps for track lightings. CFLs, they have a wide and poor beam pattern. They just don't have the punch, and the color quality wasn't there. So screw-in LED replacement directional lamps, they've improved to the point where they're now an excellent alternative to halogen. Energy savings, long lamp life, excellent color quality is what makes them a compelling choice. And they also come in a variety of shapes and sizes. Keep in mind that even if they didn't save any energy, it would still be cheaper to buy one LED replacement at $30, let's say, instead of having to buy 10 halogens at $8 over that same period of time. And think about the hassle of changing those 10 lamps. However, the LEDs do save a lot of energy, up to 80%, and they even qualify for generous prescriptive cash incentives through Energy Trust of Oregon, which often covers half the lamp cost or more. Paybacks are typically 1 to 1.5 years for retail stores after you apply incentives. And the Energy Trust may also offer a custom incentive if you need to get all new LED track fixtures. But it's important to get approved products whenever you choose LEDs, whether it's a new track head or a replacement lamp. So make sure it's an approved product and you get your project pre-approved. Okay, so let's switch now over to choices in the linear fluorescent lamp family. This is the most common commercial light source. Most 4-foot T12s are actually 34-watt energy savers. They save energy, light quality is poor, they don't work good in cold temperatures. They're also operated by inefficient magnetic ballasts, which they don't make anymore. And also most of the T12 lamps have been phased out starting in 2012. But you still can get some T12 lamps, but they're going to be more expensive or not the right lamp for your application. There's going to be some compromises there. And because T12s are so bad, we need to change these out to something more efficient. And there's a lot of options, and we're going to be covering those here on the very next slides. So the most common thing to do, and what we've been doing for years, is replacing T12s with T8s, which are smaller in diameter, as we saw, than T12s, but they're the same length and they have the same pins, so they fit in the same lamp holders as T12. So this makes them really good for retrofits. So it's important to know that any T8 lamp with electronic ballast is going to be better in every way compared with a T12 system, especially CRI, efficacy, and lamp life. But the best performing T8s are known as high performance. And the best performing ballasts are also known as high performance. And when you combine these together, you get a high performance system, and it's easy to save 40 to 50% with this type of application. Keep in mind that the high performance equipment is going to be required in order to get an incentive from the Energy Trust. And we'll go over the details about incentives toward the end of the webinar. And you can find qualifying fluorescent equipment at the website you see at the bottom of the screen. So let's look at reduced wattage T8s, another type of high performance T8. So this can be a good strategy under the right circumstances. Let's first look at a fixture that's already T8, and you want to just relamp with a lower wattage lamp. Now this is this is the cheapest first cost solution. You can save 10% or more, but this would not be a good solution if the existing ballasts are old and starting to fail. The most common ones are 28 watts and 25 watts. Keep in mind they need to be used in conditioned spaces or an enclosed fixture. And this is a good strategy if the space is currently overlit, which many are. The energy usage, light output is going to be reduced by about the same amount. So So let's look at situations where you could use reduced wattage T8s in a retrofitting strategy. This is going to include a new ballast. And this is a much better idea than simple lamping, but it's also going to involve putting in a new ballast and maybe some other modification. So you would do this because if you have a T12 system, you can't just relamp with T8s because the T8s aren't compatible with this existing magnetic ballast. You got to put a new ballast in anyway. And you might want to consider a retrofit with reduced wattage if your T8 installation is older. The ballasts are nearing end of life, and it's time for a total change. So existing T8 systems, they can qualify for energy trust incentives if you also use a reduced wattage electronic ballast. But I like to look at the full wattage T8, the 32-watt lamps first, because it's easier to reduce the number of lamps when retrofitting. Recessed Troffers, especially ones with prismatic lenses, can easily be upgraded with a kit. This is a great upgrade option. Often you're going to be able to reduce the number of lamps. You're going to get these kits that come with new lamp holders, and they're going to, especially when you go from, let's say, 3 lamps or 4 lamps down to 2 lamps, you're going to reposition the lamps where they should be. And you might want to have kits, if the fixture is inefficient, you can get ones with the reflector to improve the efficiency of the fixture. But this doesn't work really well with parabolics because the distribution is poor and you still are going to have the bare lamps. So a better upgrade option, especially with parabolics, is to put a new advanced lens in addition to the retrofit kit. This is going to improve the fixture efficiency, give it an updated look, and you can do this same strategy with LED and get incentives from Energy Trust for either fluorescent or LED. And many times, if you go with fluorescent, even though this is showing 2 lamps, very often you can go all the way down to just 1 lamp with these types of kits. Now, since I can't take all of you in the field to see some actual fixtures, this photo is going to have to be the next best thing. So let's put what we've learned so far into action by evaluating upgrade options for this typical recessed troffer. So looking at this, what can we find that gives us clues about the condition of the fixture? Well, for one thing, we see that we have a couple lamps missing, so maybe this area was overlit. And these lamp holders are probably pretty old. They probably need to be replaced. I usually recommend that. You'll see that the housing is discolored. It's not very white, doesn't reflect very well. And this particular troffer has sloped sides, which actually is good. So if this was a really white surface, this would probably not need a new reflector. It'd probably be good all by itself. But this one looks pretty dirty. Pretty obvious here, we don't have a lens. It's gone. And the upper corner here, maybe one of these latches is not working. It isn't closing all the way. A lot of these are plastic and they break off. And so what would you do? This maybe we retrofit this. You could. You could put a new lens in here, a new kit, maybe go to LED. So we've got some options here. So what about T5s? Since they're thinner, wouldn't they always be better? Well, sometimes. There's 2 basic types. There's the standard T5, and then there's really bright T5s that are called high output, or HOs. But they don't fit in the standard T12 or T8 lamp holders because they have miniature bipins and they're about 2 inches shorter than the standard 4-foot T8 lamp. So this is not meant to be a retrofit lamp. It's going to be best when it's used in new fixtures. So examples of the type of fixtures where T5s work really well is indirect fixture, especially if you can put just 1 lamp end to end in rows with the indirect lighting system. We already talked about advanced lens. They make, this is just one example, they make other types that are made just for T5s. They're made to get the most light out of a T5 fixture. And high bays work really well for T5 HOs. You can replace a 400 watt metal halide with either a 4-lamp T5 HO or a 6-lamp high performance T8 fixture that has high ballast factor ballast. Note that even though we're talking about T5s, T8s usually work just as well and often better than T5s and T5 HOs in these applications. And you could also consider new LED fixtures if you have long hours of operation. We'll look at one more fixture type here, the industrial type strip fixture. These are great candidates for retrofit, especially ones that have 8-foot T8 lamps. They might have your basic slimline single pin lamp, or you might have an HO, VHO T12 lamp. So what we're going to do with this retrofit is we're going to replace each of these 8-foot T12 lamps with 2 4-foot lamps. And that's because the 4-footers are the best performing, they're easier to handle, you can reduce your lamp inventory, and it's an easy retrofit. You attach this kit to the old channel, you might add a new lamp holder, you'll have new lamp holders, and you might want to add a new reflector. So from down below, this is going to look just like an entirely new fixture. Okay, so here we are out in the field again, and here's this industrial type fixture. So what are the clues that we're seeing here? We're going to see, number one, that we have a very discolored and dirty reflector, not really reflecting very much. The lamps are blackened, and at the very least, they need to be replaced. But often you see these lamp holders, and I think you can tell in this picture it's kind of pushed out. That happens a lot with this type of fixture. Sometimes the lamps even fall out. But again, you can take this down to just the basic channel and put a new kit in, new reflector. Again, it looks just like new, but sometimes you want to just put a whole new fixture, especially if it's high up in the air. But one of the things to consider is that if you retrofit, you can have a lower waged technician to do it, whereas if you put in a new fixture, you're going to have a journeyman electrician, and that's going to cost you a little bit more. So again, weigh the pros and cons, and sometimes it makes more sense to retrofit, and sometimes a new fixture is going to be best.
Mark, what are some other types of industrial fixtures, and can those be retrofitted too? Yeah, a lot of the other type of fixtures. You might have ones that are in a hazardous location or vapor tights. You might have some that are in damp or dusty environments. Typically, those are best just getting a whole new fixture. Especially if you have a damp or dusty environment, you're going to have to replace so many parts, it's usually best to get a whole new fixture. And then there's high bays and low bays. Thanks, Beth. Okay, to summarize what we've learned so far, if you don't know this already, any T12 fixtures, they've got to go. Always go with high performance with your T8s. Look at the full wattage before you look at the reduced wattage as your first choice. Rule out any retrofit options before you consider a new fixture. Decide if lower light levels would be appropriate. Just don't automatically go for the same light level. Very often you can reduce light levels and still have a good lighted environment. So don't just, so look for ways that you can delamp. And with lower light levels, maybe you can add a task lamp for those critical reading tasks. And also consider LED Troffer upgrade options if you have long hours of operation. So what about LED applications? And we cover this more in seminars and a dedicated LED webinar, but we've already looked at directional lamps, and again, they're a great application. Others are recessed cans. This is where LEDs can work really well, especially if you're replacing incandescent lamps. Because
LEDs like it cold refrigerated display cases is a great LED option. Outdoor signage, very good place. Again, they like it cold. Recessed troffers, we've touched on that a little bit. These generally need to come down in price a little bit more, but if you have long hours of operation, it's definitely something to consider right now. Outdoor fixtures, parking garages, gas station canopies, wall packs, area lightings, these have all been shown to be cost effective and save a lot of energy. And don't forget the good old exit sign. Note that all the above applications have Energy Trust prescriptive incentives available. Now in the near future, as costs go down, performance goes up, you're going to see more and more outdoor fixtures, especially the more expensive architectural types and the ones with higher wattages. High bays are starting to become cost effective, again, long hours of operation. Indirect lighting, as the cost of the fixtures come down, you'll see this more and more. And there's a lot of specialty applications that don't fit into neat applications, neat categories. We're seeing some different applications that we haven't thought of before because they weren't possible before LEDs. Now, TLEDs, these are tubular LEDs. They're known as LED T8s. As much as I'd like to go on and on about this, we don't have time, but keep in mind that this is something that is a possible upgrade for your linear fluorescent options. But you need to look at other options first before you look at your LED T8s or your TLEDs. And again, for more information, check out the LED webinar and some LED seminars that PG has throughout the year. So now let's look at some lighting control options. Because we have limited time, we're only going to talk about occupancy sensors. So these turn the lights off or lower when no one's available, no one's at home, and they're getting smarter, more reliable. But you need to pick the right one for your application. Here we have one that replaces a wall switch, one that goes in the ceiling, and here's a type that would attach to a high bay fixture. So here we're going to talk about some of the technologies. With passive infrared type sensors, they need line of sight in order to detect occupancy. And again, they can replace a regular switch. They can be attached to the ceiling, high up on the wall, or directly to a light fixture. But because the further you get away, they don't see small movements, so they can be prone to false off. So the farther away you get, you may have to wave your arms to turn the lights back on. Also, you can increase your savings if you choose a vacancy sensor instead of an occupancy sensor. A vacancy sensor, you're going to have to manually turn on, where a vacancy an occupancy sensor turns on automatically. And passive infrared are the cheapest type of sensor. I lost it here. Here we go. And here's some of the applications: small private offices without obstructions, large offices, open restrooms, hallways, and fixture-mounted high bays. So ultrasonic sensors work a little differently. They detect a disturbance in the force, so to speak, kind of like Doppler radar, especially movement toward or away from the sensor. Because the sensor range can leak from the intended coverage area, they can be sometimes have false ons. And these are more expensive than passive infrared. And here are some of the applications: large conference rooms, storage spaces that may have obstructions. Now, sometimes combining these two sensor technologies gives you the best performance. So in this case, we're going to combine infrared with ultrasonic. And by doing this, you're going to limit your false ons with passive infrared and the false offs. I'm sorry, the false ons that you get with ultrasonic and the false offs that you have with passive infrared. But as you can imagine, this is going to cost more. But where you see these are in classrooms,
conference rooms, restrooms that have stalls, and maybe a small office that has obstructions. Relatively recent development in occupancy sensors are ones that are wireless. So it's always been difficult and expensive to retrofit using ceiling sensors because of the need to add new wires and even conduit sometimes. So to encourage the use of wireless controls, Energy Trust offers a wireless sensor incentive of $100. There's two basic ways of providing power to these sensors. One is having a long life battery, and Lutron is an example of someone that uses this approach, and the other way is to have self-powered switches and sensors, such as the one that Leviton has. Now the cost of these sensors has come down recently, so this is an option you definitely want to check out. Now savings for the occupancy sensors can depend a lot on the application as well as the usage pattern. That's why you see kind of a wide range of energy savings. And the savings can depend a lot on the ownership of a space. For instance, a private office, if you have a very diligent person that is the only person in there, they can be very diligent about turning the lights on and off whenever they leave and come back. Versus a conference room that people may not know if they should turn the lights on or off. And it's like, not my space, I don't care. So that can have a factor. And sometimes, like a conference room, maybe just putting up a sign that says, please turn off the lights when you leave, lets people know that it's okay to do that, and they will turn the lights off. Now, in some spaces like warehouses, that savings can be very significant, up to 75% in parts of a warehouse that aren't used very much. So these percentages, they can be based on a educated estimate, or if you need to get more accurate information, you can put light loggers in fixtures to quantify the usage time and also the usage pattern. Okay, so to summarize our lighting controls, they work very well if you specify the right type. Also install them correctly. Having them point the right direction might be a good thing, right location. And also commissioning. These sensors are often adjustable. You can adjust the amount of timeouts, the sensitivity, and even the field of view that they have. So there's great energy savings potential when it's done right. And again, there's generous Energy Trust incentives for these. If you want more information you'd probably ever want to know about controls, but it's a very good websites here, Lighting Controls Association, and also the Advanced Lighting Guidelines has good information on that. Yes?
Mark, can sensors be used with exterior fixtures?
Yes, you can certainly use controls with exterior fixtures. If you have an occupancy sensor outdoors, it's more accurately known as a motion detector. Very often with exterior, you're also going to have a photocell that automatically turns the fixture off during the daytime when you obviously don't need it. And you could also add an astronomical time clock, which will turn the lights on and off according to the sunrise and sunset, and do that with the timer. And you can do that in combination with a photo sensor, actually. Thanks, Beth. So to begin to wrap things up, and we're in the home stretch, here's a visual summary to help you remember what we talked about today. If you have an existing T12 or older T8 systems, look at your high performance T8s, maybe reduced wattage T8s and ballasts, and retrofit kits or new fixtures. And this could be fluorescent or LED. If you have incandescent bulbs, whether they're simple bulbs or they're maybe reflector lamps, you have these choices of the halogens. Compact fluorescents sometimes are a good choice. More and more, you're going to find that light-emitting diodes are going to be your best application, best choice. And if you have areas that are often vacant, look at occupancy sensors. And other types of controls that are good are photo sensors, timers, and maybe just good old signage could work. So there's a lot more lighting upgrade options we didn't have time to cover today. And again, these are covered in much more detail in our half-day seminars and some of our other lighting webinars. So in PG service territory, our commercial and industrial customers can take advantage of cash incentives offered by Energy Trust of Oregon. Some of the standard prescriptive examples are, again, high-performance T8 lighting systems, LEDs with recessed downlights, directional lamps, and your outdoor fixtures. You can get incentives for fluorescent or LED Troffers and Troffer kits and lighting controls. If you see something that's not on the list, some non-standard measures like high bays, you can still qualify for incentives through Energy Trust. And it's easy to qualify for incentives. It just needs a simple payback of more than a year, needs to save 25%, and it needs to be cost effective. And if you use linear fluorescent, you need to use approved products. And if you're going to use LEDs, you also have to have qualified LEDs. And these are websites where you can find out if what you're considering is a approved lighting product or not. And maybe most important, don't forget to have your project pre-approved before you start work or order any equipment. So by now, hopefully, most of you are thinking of some energy-saving opportunities for your facility. Contacting PGE to discuss your best next steps would be a good place to start. While our website has some good information, I would recommend that you contact us directly by phone or email. Commercial customers, you can contact Paula Conway. Industrial customers, you can contact Darren Spencer. So customers of Pacific Core, Northwest Natural Gas, and Cascade Gas can also use Energy Trust of Oregon programs. When in doubt, contact your local utility for available resources. And now it's time for your questions, so I'll turn the mic back over to Beth.
Thanks, Mark. And before we proceed to the question and answer portion of the webinar, I'd like to remind you that you can continue to submit questions to me through chat, and I'll ask them of Mark, or if you would like to, you can raise your hand. So Mark, it looks like the first question we have is, do all T8s require retrofitting to electric ballasts?
Yes, the answer is yes. So, all your T8s have to have an electronic ballast. They're not going to work on that magnetic ballast. Actually, they will work, they'll light, but they have the magnetic ballast has a higher amperage, so it's going to burn those T8 lamps out really, really fast. So not a good idea. So if you have T12s, you're going to have to put a new electronic ballast in.
Thanks, Mark. And next question is, are ballasts more expensive than lamps? And if so, by how much?
The ballasts are more expensive, maybe 3 to 4 times more expensive than the lamps, depending on the type and quality of the lamp. You can usually get a high-performance T8 lamp for less than $4, and electronic ballasts are usually less than $15. Is pretty typical.
Great, thanks, Mark. And it looks like our next question is, if T8s can last 50,000 hours, do ballasts last longer? And if so, how much? A lot of questions about ballasts.
Yeah. Well, it used to be that you could get 3 or 4 relampings to last that you would need for the amount of time that a ballast would last. But now you can get lamps that last almost as long as the ballast itself. But some of the ballasts are going to last. They should last at least 50,000. Some even maybe up to 75,000 hours. But if you have a really long life T8 lamp, by the time you need to replace the lamp, it might be a good time to replace the ballast as well. Or by then, it's probably going to be a good time to go to LED.
Great, thanks, Mark. Our next question is about outdoor lighting. What about outdoor lighting controls? Is there a way to replace standard pin timers to adjust for different day duration over the year?
we mentioned briefly outdoor lighting controls. One of the most important things is not to have a day burner, not to have them on when the sun's out. So photosensor is the thing that's most common to do that, but most people end up getting the cheapest photosensor they can, and they don't last very long. So that'd be, they might last for 5 years or so. In fact, for a good example is for PGE streetlights, since we normally visit the light pole about every 5 years, we have a photosensor that lasts about that long. So when we change the lamp, we also change the photocell. But now, since we're going to LED street lights that are going to last a lot longer, we're not visiting that pole every 5 years like we used to. So when we put in the new LED fixture heads, we also got a long life, a 20-year photocell. So yeah, they cost more, but I highly recommend getting a better quality photo control for your outdoor lights. It's going to, number one, not have your lights on during the day, but it's going to also reduce your maintenance as well.
Thank you, Mark. And that was our last question. I'd like to thank you all for joining us today.